You should be fluent with doing various arithmetic operations with rational expressions such as multiplication, addition, subtraction, division. The easiest one is multiplication. So if I have two rational expressions being multiplied together, all I need to do is multiply the numerators together, the denominators together, and you're done. So in this case, I'm going to take minus 3, and I'm going to multiply it by 4x plus 1. And just initially, I'm going to write that as 4x plus 1 in parentheses times minus 3. In the denominator, I take x plus 2, that whole quantity, and I multiply it by x minus 2. So include the parentheses. And in a sense, this is actually a pretty good expression to have. And in fact, I would encourage you that unless you have reason otherwise, having things in this factored form is usually pretty good because you can clearly now see the domain of the expression and you can see where the numerator is 0 easily. So usually factored is a good idea, but just to exercise the skills, we'll complete the simplification by distributing things out. So it'll be minus 12x and then minus 3 in the numerator, and then let's FOIL in the denominator, x squared. 2x and minus 2x will cancel out, and I'll have minus 4 difference of squares here in the denominator. And now it's completely simplified. If you want to perform addition or subtraction, you have to work a little bit harder. So for example, I'm going to take out two rational expressions above and subtract them now. Now you need to find a common denominator in order to combine the terms. You look at each term and you ask yourself which factors in the denominator are missing. So for example, this one, x plus 2, is missing the factor of x minus 2, and vice versa for this one, x plus 2 is missing from this one. So what you're going to do is take each term and multiply the top and bottom by any missing factors to create a common denominator. So the first one I'm going to multiply by x minus 2 over x minus 2. I'm just multiplying by 1, so it doesn't change the expression at all. And the other term, I'm going to multiply the top and bottom by its missing factor, which is x plus 2 over x plus 2. Again, I'm just multiplying by 1, so I'm not changing the expression, and these two things really are equal to each other. We now go ahead and do the multiplication in each one. So I'm going to have minus 3 times x minus 2 over there, and its denominator will be this product of factors, x plus 2 times x minus 2. In the second one, 4x plus 1 times x plus 2, and it now has the same denominator, x minus 2, x plus 2. So because their denominators are the same, we can just subtract the two terms in the numerator. And put it all over that common denominator. This expression is absolutely not simplified and is not a suitable expression. It's fine that the denominator is factored like this, but the numerator requires simplification. There are many like terms here that potentially could be combined and simplified. So what we're going to do now is just do the polynomial simplification in the numerator. Minus 3x plus 6 minus, and then we'll start FOILing this out, 4x squared plus 9x. I get 8x plus 1x for 9x and plus 2. Denominator is x squared minus 4 as we saw before. Now start simplifying. The negative sign here will distribute through each term, so it'll be minus 4x squared minus 9x and minus 2. It's all over x squared minus 4. And then just start to arrange that numerator, simplify, combine any like terms. I see 1 degree 2 term, so that's minus 4x squared. I see minus 9 minus 3, so minus 12x. And then 6 minus 2 gets me 4, and all over x squared minus 4. And now we've simplified the expression completely. Let's look at another addition example. Let's take 2x over x squared minus 4 plus 3x over 2x plus 4. Again, when you're doing addition of rational expressions, you need to find a common denominator, but that doesn't necessarily just mean taking this denominator here and supplying it over here, and this denominator here and supplying it over here. You always want to try to do this in an efficient way, and usually that means by finding the least common multiple of the two denominators, and that requires factoring. So the first thing I'm going to do is factor x squared minus 4 as x plus 2 times x minus 2. And in the other term, I have 3x, and I have 2 times x plus 2. So I've factored out a factor of 2. And doing that helps me kind of survey the denominators here and take stock of what's missing from each one. So in this one here, I have the x plus 2 that this one shares, but I'm missing the factor of 2. So what I'm going to do is take that first term and multiply the top and bottom by 2. I then look at the second term. It has the 2, it has the x plus 2, but it's missing the x minus 2 factor, so I'm going to supply that by multiplying the top and bottom of that by x minus 2. Now I see the same 3 factors in both the denominator, so I'll be able to add them together with that as its denominator. I'll take the numerators and add them together, and I'll do a little bit of multiplication as well. 2x times 2 gets me 4x, and then it'll be 3x times x minus 2 that gets added to it. Just expanding out now. And then we can combine a like term in the numerator. So it'll be 3x squared minus 2x. The denominator is 2 times x squared minus 4, just multiplying this out again. And if you want to distribute the 2, 2x squared minus 8.